Homework 7.5, Rational Functions, Video 7. Homework due Wednesday, May 27th, 2020 at 11:59 p.m. The following video is associated with questions 13 through 16 in Homework 3.5. In the previous video, we looked at Desmos and we made some conjectures about how to locate the equation of a horizontal asymptote from a rational function. And initially it boiled down to leading coefficients, but then we discovered that, well, we also have to check the degree of the numerator versus the degree of the denominator. So on the board back here, I've got a little table set up that we're going to complete, but we have to suppose that f of x equals a rational function. Again, n of x over d of x, n for numerator, d for denominator, where both of those are polynomials, so they each have a degree. There are three scenarios depending upon where the greater degree is, in the numerator, in the denominator, or they may have the same degrees. So to summarize what we said at the end of the previous video, if the numerator has a greater degree, then there is no horizontal asymptote. That means that the ends of the graph do not taper off, they either rise or fall. If the denominator has the greater degree, then the horizontal asymptote is y equals 0 every single time. Nothing to calculate, it's 0. But if the numerator and the denominator have the same degree, then the horizontal asymptote is y equals the ratio of leading coefficients. Remember, the leading coefficient is the number in front of the x with the highest power. So I've got three examples over here, one for each case. For example, f of x equals x squared minus 1 over x plus 5. The greater degree is in the numerator, and when the numerator has the greater degree, there is no horizontal asymptote. So this one, no horizontal asymptote. The ends either rise or fall. In the second example, I just moved the square to the denominator. F of x equals x minus 1 over x squared plus 5. When locating horizontal asymptotes, you see who has the greater degree. The denominator has the greater degree of 2. The numerator's degree is 1. And when the denominator has the greater degree, the horizontal asymptote is always y equals 0. I meant to put an HA column over here. Y equals 0. In the third example, f of x equals x squared minus 1 over x squared plus 5. And the numerator and denominator have the same degree. Both of them have a highest power of 2. When the numerator and the denominator have the same degree, the horizontal asymptote is y equals the ratio of leading coefficients. So, you look in front of each term that has the highest power, you grab their coefficients, in this case they're both an implied 1, so the horizontal asymptote is y equals 1 over 1, which of course reduces to 1. So locating horizontal asymptotes is easy if you can spot the degrees and the leading coefficients. Now, we ran into a situation quite a few videos back when we were looking for the leading term of something that was factored. So just as a reminder, if you had something like f of x equals, we'll say 3x plus 1 over x plus 2, and on the bottom we had something like x squared plus 4 over x minus 1. Now I don't think you'll run into anything this messy, but if you had something like this and you were looking for the horizontal asymptote, you would need to know what the leading terms are. And you can actually, these are small enough you can multiply out, but you can always create the leading term by just multiplying the leading terms of each factors. So in the numerator, the leading term would be 3x squared plus some more stuff. In the denominator, x squared times x is x cubed plus more stuff. And if I only need the leading terms, then this is all I need. The degree is greater in the denominator, so the horizontal asymptote would be y equals 0. But again, I don't think, I may be wrong, Any of the questions in your homework will ask you the horizontal asymptote and it's factored, in which case you have to manufacture the leading terms. But it's a story we've seen before, so hopefully you remember that story.